the reliance on community-built drivers. The hardware is theoretically capable, but the software needs a specialized translator to unlock that power. The listener also pointed out a highly specific configuration choice, scaling the virtual resolution down to 800 by 600. In an era where mobile screens boast 2K and 4K resolutions, dropping a game down to 800 by 600 seems counterintuitive. I assume this is a strategic sacrifice to maintain performance during the game's most demanding moments.
It is a highly calculated trade-off. Manhunt 2 utilizes distinct visual filters to create its grimy, static-filled VHS aesthetic. Those post-processing effects require significant computational power. By forcing the internal resolution of the Windows container down to 800 by 600, you are drastically reducing the number of pixels the GPU has to render on every single frame. This frees up resources to process the complex translation layers we just discussed. In a stealth game, timing is everything. If the game drops frames right as you step out of the shadows to perform an execution, the gameplay loop breaks. The listener understood that a smooth, fluid frame rate at a lower resolution is far superior to a high-resolution slideshow. Furthermore, 800 by 600 was a standard PC resolution back in the mid-2000s, so the game's interface and textures scale naturally to that size without looking distorted.
It is a brilliant piece of optimization. You are essentially recreating a mid-2000s monitor environment inside a cutting-edge mobile environment to trick the game into running flawlessly. But the configuration does not stop at the emulator settings. The listener stressed the importance of aggressive memory management, specifically using an application to kill all background processes to free up RAM. They claimed the game would choke during stealth segments if the phone's memory was not completely clean. How memory-intensive is this translation process?
The memory demands are exorbitant. When you launch a game via winaltor, you are not just loading the game's assets into RAM. You are loading the Ubuntu root file system, the Wine compatibility layer, the Box86 translation layer, the graphics wrappers like DXVK, and the game itself. Modern Android operating systems are designed to keep multiple apps suspended in the background for quick switching, which eats up available RAM. If a device has 8 gigabytes of RAM, the operating system might reserve 3 or 4 just for background tasks. By actively killing those background apps, the user ensures that winaltor has an uncontested claim to the device's memory pool. If the emulator runs out of physical RAM, the Android system will attempt to use swap memory or aggressively shut down the emulator to prevent a system crash. In a game like Manhunt 2, where sudden spikes in action require immediate asset loading, a lack of available RAM will cause severe stuttering or complete freezing.
The dedication required to play this game is fascinating. It requires a deep understanding of mobile architecture, manual driver installation, and strict system hygiene. It forces the user to act as their own systems administrator just to play a controversial stealth title. This brings up an interesting tension regarding game preservation. Manhunt 2 is not readily available on modern digital storefronts due to its history and content. The only way to experience this piece of gaming history in its original, uncensored form is often through these complex emulation pathways. Is emulation the only viable future for titles that the industry prefers to leave buried?
Emulation is unequivocally the most robust safeguard for gaming history, especially for controversial titles. Publishers have very little financial incentive to navigate the legal and cultural minefields of re-releasing a game like Manhunt 2. Doing so would invite renewed scrutiny and potential boycotts, yielding minimal return on investment. Consequently, the source code and physical media slowly degrade or become incompatible with modern hardware. The open source community, through projects like winaltor, Box86, and DXVK, operates outside of corporate risk assessments. They build tools that ensure x86 applications remain functional regardless of shifts in the underlying hardware market. This means the cultural artifacts of the medium, regardless of their controversial nature, are preserved for study and interaction. The work of developers like Petitseb, who created Box86, and the contributors maintaining the turnip drivers, is functionally archival work. They are building the infrastructure that allows a 2009 PC game to survive on a 2026 mobile processor.
That archival perspective is crucial. We often view emulators purely as entertainment engines, but they are closer to digital museums. However, this specific museum exhibit requires you to compile Linux libraries, adjust Vulkan translation layers, and manually allocate RAM. It is a highly exclusionary museum. The average consumer is not going to download a GitHub repository, source a clean 2009 PC executable, install an Adreno-specific driver patch, and configure a customized Ubuntu container just to play a video game. Does the complexity of this process undermine the preservation argument?
The complexity is a barrier, certainly, but it is a temporary one. If you look at the trajectory of emulation, the friction always decreases over time. 5 years ago, running a DirectX 9 Windows game on an Android phone was a theoretical concept. Now it requires following a precise checklist, like the one our listener provided. The winlator ludashi fork already implements features like built-in driver downloads and configuration profiles, streamlining what used to be a heavily manual process. As these translation layers mature, the end goal is a seamless user experience where the back-end complexity is completely hidden. However, for now, that barrier to entry actually fosters a highly dedicated subculture. Communities form around sharing optimal configurations, discovering which specific driver version prevents a crash, and testing the limits of new hardware. The listener sharing their exact parameters for Manhunt 2 is a perfect example of this collaborative grassroots preservation.
It is a collaborative effort to keep a digital ghost alive. The irony is palpable. A game designed to shock and offend the moral sensibilities of the 2000s is now the subject of meticulous, loving optimization by hardware enthusiasts. They are not focused on the shock value of the violence. They are focused on the mathematical puzzle of getting the rendering engine to maintain a steady frame rate through a Vulkan wrapper. It strips the game of its original controversy and recontextualizes it as a pure technical benchmark.
That recontextualization happens frequently in the emulation scene. A game's cultural baggage often fades, leaving behind its underlying code as the primary point of interest. Manhunt 2, with its heavy reliance on specific visual filters and lighting engines, serves as an excellent stress test for these translation layers. If developers can get the turnip drivers and DXVK to render the chaotic, static-laced environments of Cursor City without crashing a mobile GPU, they know their compatibility layer is robust. The game becomes a diagnostic tool. The intense scrutiny that once came from politicians in the British Parliament or the United States Senate has been replaced by the intense scrutiny of open-source developers analyzing memory leaks and shader compilation errors.
The shift from political controversy to technical analysis highlights how time neutralizes the initial shock of interactive media. What was once deemed a threat to public morality by figures like Jack Thompson is now just a demanding executable file requiring precise CPU scaling. The listener's guide to optimizing winlator ludashi is a testament to the resilience of both the software and the community that refuses to let it fade into obsolescence. It requires dedication, strict memory management, and a willingness to engage with the raw mechanics of the hardware. The payoff is absolute freedom from platform restrictions and the ability to carry a controversial piece of history in your pocket.
Ultimately, the intersection of projects like winlator, Box86, and the turnip drivers proves that the boundaries between desktop and mobile computing are dissolving rapidly. The hardware has been capable for a while. The open source community is finally providing the software infrastructure to unlock it. The preservation of a controversial title like Manhunt 2 is just one highly specific, highly fascinating byproduct of that broader technological shift.
It is a shift that puts the power of an entire operating system and the legacy of its most debated software squarely in the hands of anyone willing to learn the architecture. If this breakdown of the technical acrobatics required to run classic PC games on modern hardware sparked your interest, send this episode to a friend who loves digging into the mechanics of emulation.